Dear students, today we will start the new chapter Trigonometry 2nd from paper 1st. In our previous lecture, we have studied the chapter Trigonometry 1 and in that we have studied the basic concepts of trigonometry. Okay. In this chapter, we will see what is meant by compound angles, then allied angles, trigonometric functions of multiple angles and trigonometric functions of angles of triangle. Also we will see the factorization formulae. Let's see one by one. In today's lecture we will see what is meant by compound angles. Okay. Compound angles are sum or difference of given angles. What is meant by compound angles? Compound angles are sum or difference of given angles. Suppose if two angles are given, if A and B are two angles, if we take their sum or difference, then these angles are called compound angles. If angles are theta 1 and theta 2, take sum theta 1 theta 2, difference theta 1 minus theta 2. Then these angles are called compound angles. For example, see, if we have to find the angle of 75 degree, if we have to find the angle of 75 degree, in our table of 0 to 90 degree, there is not the angle of 75 degree. Then how we will find the trigonometric function of angle 75 degree? If I have to find sine 75 degree, then I can write this angle as 45 plus 30 degree. Okay. Means we are taking sum of these two angles, and in that table we know the value of 45 degree and 30 degree, and in this way if we divide this 75 degree into two angles, that is sum of 45 and 30 degree, then we are able to find the value of sine 75 degree using the table. Okay, now if I have to find sine 15 degree, then how we will be able to find this? For that I can take difference of these two angles. In this way, this angle of 75 degree and 15 degree can be written as sum or difference of given angles. Therefore, these angles are called compound angles. Now, to find the angle of 75 degree, here we need the formula for sine A plus B. What is this? This is sine A plus B. This is sine A minus B. Means we need here the formula of A plus B and A minus B. Similarly, cos 75 degree or cos 15 degree, then tan 75 degree and tan 15 degree. Means here in all these cases we need these formulas for sine, cos and tan. For all these trigonometric functions we need a formula of A plus B and A minus B. We need a formula for A plus B and A minus B. Okay, if we know the formula for A plus B and A minus B, then we are able to find the trigonometric function of any angle. If there is an angle of 120 degree, then this can be written as 90 degree plus 30 degree. If angle is 150 degree, then this can be written as 90 plus 60 degree, like that. If angle is 225 degree, then this can be written as 180 plus 45 degree. And we know the value of trigonometric functions at 90, 60, 180, 45 from our table 0 to 360 degree. Means here we are dividing this angle into two angles such that their addition and subtraction should be the required angle. And to find the value of 75, 15, 120, 150, 225 or like that, we need the formula for A plus B and A minus B. And if you know the formula for sine, cos and tan in terms of A plus B and A minus B, then we are able to find the value of such type of angles. Okay? And there is a theorem or formula. Let's see the first formula, and that first formula is given as theorem. What is theorem first? For any two angles A and B, cos A minus B is equal to cos A cos B plus sin A sin B. We have to prove this. This is our first formula. Now consider plane coordinate system, x-axis, y-axis, this is origin. Now for the proof, you consider standard unit circle. You write down, consider standard unit circle. Standard circle means center having at origin, and unit circle means its radius is 1. Okay. Now we will take 2 points on the circumference of circle, that is P and Q. You write down, let P and Q be any 2 points on this circle. Suppose point P is here and point Q is here. We will join this OP and OQ, and suppose this OP makes angle A. This OP makes angle A with positive direction of x-axis, and this OQ makes angle B with positive direction of x-axis. Then you write down, major angle XOP is A and major angle XOQ is B, because here OP makes angle A with positive direction of x-axis and OQ makes angle B with positive direction of x-axis. Okay. Now these are radius of circles, therefore that is equal to 1. Okay. Now see here, we have seen in our previous lecture that if this P makes angle A with positive direction of x-axis, therefore what will be coordinates of point P? Then coordinates of point P will be cos A sin A. If P is any point on the circumference of the circle and this is theta, and if we draw the perpendicular, then this is x, this is y, and this is r. Here r is 1, and if r is 1, if it is standard unit circle, then x means cos theta and y means sin theta. And if P has coordinates xy, then that can be written as P cos theta sin theta. Okay. Now here, instead of theta, angle is A and P makes angle A with positive direction of x-axis. Therefore, coordinates of P will be cos A sin A. And here Q makes angle B with positive direction of x-axis. Therefore, coordinates of Q will be cos B sin B. If I want to find the distance between these 2 points P and Q, that is the length of chord PQ, then here we need the coordinates of point P and coordinates of point Q. Here point P makes angle A with positive direction of x-axis. Therefore, coordinates of point P will be cos A sin A. And OQ makes angle B with positive direction of x-axis. Therefore, coordinates of Q will be cos B sin B. Now, by distance formula, we can find this length of chord PQ or distance PQ. Okay. Therefore, you write down by distance formula. This distance PQ can be written as under root difference of x coordinate, its square, plus difference of y coordinate and its square. Now if I take the square of both sides, then what will be this? Distance PQ, its square, and here. Now you expand the bracket, what will be this? This will be cos square A minus 2 cos A cos B plus cos square B. This is expansion of first bracket. Okay. Now we will take expansion of second bracket, that will be sin square A minus 2 sin A sin B plus sin square B. Now take this cos square A and sin square A in one of the bracket and this cos square B and sin square B in one of the bracket. Now this will be cos square A plus sin square A. In the second bracket, cos square B plus sin square B. And from these two terms, I will take minus 2 common. Then this will be minus 2 times cos A cos B, and this will be plus sin A sin B. Okay. Now by our first identity, value of this sin square A plus cos square A will be 1. This will be 1, and write down this term as it is. This 1 plus 1 means 2. 2 minus 2, cos A, cos B plus sin A, sin B. Okay. Now, treat this as equation 1. This is nothing but distance PQ bracket square. Consider this as equation 1. But see, in the formula, we need the angle A minus B. In the formula, we need the angle A minus B. And what is the angle A minus B? See here, this XOP is A, XOQ is B, this angle is B, this angle is A, means this angle is A minus B. And in the formula, we need the angle A minus B. Okay. Now, see here, OP makes angle A with positive direction of x-axis, OQ makes also angle B with positive direction of x-axis. But here, if we want to find the angle A minus B, then this OQ is not the positive direction of x-axis. If we consider this OQ as initial arm and OP as terminal arm, this OQ is not lying on positive direction of x-axis. Means here we have to modify the diagram or reconstruct the diagram, and for that, to find the angle A minus B, the angle should be directed angle, and if angle is directed angle, its initial arm should lie along positive direction of x-axis. Therefore, here we will shift this OX along OQ. Means this OQ is our new x-axis. Now we are modifying this diagram such that we are shifting this x-axis along OQ. Similarly, you drop y-axis perpendicular to this x-axis. But here there is no need of y-axis, therefore I am not drawing that y-axis. If I draw the y-axis, then diagram become more complicated. Therefore, for your simplicity, I am only showing x-axis in this diagram. OQ is our new x-axis. Okay. And then for this angle A minus B, this OQ will be the initial arm and OP will be the terminal arm. Okay. And this initial arm is along our new x-axis. Then what will be new coordinates of point Q? You write down shift OX, that is x-axis along OQ. Okay. Therefore, OQ is new x-axis. Okay. Shift OX, that is x-axis along OQ. Therefore, OQ is new x-axis. Okay. And you draw y-axis perpendicular to x-axis. Here in the diagram, I am not drawing y-axis. You only imagine that there is y-axis perpendicular to this new axis in this way. Okay. In this way, there is y-axis perpendicular to this. The new coordinates of Q will be what? Now, this OQ is nothing but radius and it is 1 and Q lies along x-axis. Therefore, new coordinates of Q will be 1, y coordinate will be 0. And what will be new coordinates of point P? See, point P makes angle A minus B with new x-axis. Means angle is A minus B. Therefore, x coordinate will be cos A minus B and y coordinate will be sin A minus B. Now with respect to these new coordinates, we will find again this length PQ or this distance PQ. Okay, with reference to these new coordinates, we will find the distance PQ. Okay, now what will be this distance PQ? Again by distance formula, this will be under root difference of x coordinate, its square, plus difference of y coordinate and its square. Squaring both sides, we will get, this will be cos A minus B minus 1 bracket square plus sin A minus B its square. Okay. Then this is nothing but cos square A minus B minus 2 times first term into second term. First term is cos A minus B and second term is simply 1 plus sin square A minus B. Now I will take these two terms together and this will be plus 1. Okay. Use the first identity, sin square A minus B plus cos square A minus B will be 1. Take these two terms together. plus 1, write down this minus cos a minus b. Okay. Now using first identity, value of sin square a minus b plus cos square a minus b will be 1. You write down 1 plus 1 minus 2 cos a minus b. And this 1 plus 1 becomes 2 here. Therefore 2 minus 2 cos a minus b. In this way we have got distance of PQ bracket square is equal to 2 minus 2 cos a minus b. Consider this as equation 2. Now see, our first equation is what? This is our first equation and this is our second equation. See, for these two equations, left hand side is equal. Left hand side is equal. Therefore, we will equate the right hand side. Therefore, you write down from equation 1 and 2. Okay. From equation 1 and 2. See, what is this? 2 minus 2 cos a minus b. And this is equal to this. That is 2 minus 2 in the bracket cos a cos b plus sin a sin b. For equation 1 and 2, left hand sides are equal. Therefore, we are equating right hand side. That is this side equal to this. Okay. Now, we will simplify this. Now, this 2 will get cancelled. This will be minus 2 cos a minus b is equal to minus 2 in the bracket cos a cos b plus sin a sin b. Now in the next step you cancel this minus 2 and you will get cos a minus b is equal to cos a cos b plus sin a sin b. And what is this? This is nothing but our formula which we have to, okay, we have to prove this formula. For any two angles A and B, cos A minus B is equal to cos A cos B plus sin A sin B, and we have got that. Okay. In this way, we have proved the theorem. Okay. Or you remember this as a formula. This is our basic formula. Okay. Such type of theorem will be asked in the exam for 4 marks, and diagram is necessary. Okay. This is our basic formula and very important. And using this formula, we will find the remaining formulas. And we will derive the proofs of remaining theorems. Okay. Can you understand this theorem? It is very easy. Now, see the theorem 2. For any two angles A and B, cos A plus B is equal to cos A cos B minus sin A sin B. Now, it is very simple proof of this theorem. Just here we have seen the formula cos A minus B can be written as cos A cos B plus sin A sin B. This is our basic formula which we have just derived. Okay. If you remember this formula, then it is very easy to derive the proof. Okay. Now see here what is given. This cos A plus B can be rearranged as cos A minus of minus B. This cos A plus B can be written as cos A minus of minus B. Okay. Now use this formula for this. What will be this? This will be, see here, cos A cos B. What is B here? Minus B. Plus sin A sin B. Instead of B, you write down. Now you compare this. See here, cos A minus B. We are using this formula. Here A is same, but instead of B, you have to write minus B. In this formula, instead of B, you write down minus B. Okay. Now we know, what we know? We know the property that cos minus theta is cos theta and sin minus theta is minus sin theta. Now this becomes cos A and this cos B using this formula becomes cos B plus sin A, and according to this formula this becomes minus sin B. Okay. Now in the next step you write down this cos A cos B and this sign becomes here minus sin A sin B. In this way we have proved the formula for cos A plus B. Okay. It is very simple. You only rearrange the terms. Instead of plus B you write down minus of minus B and use the same formula. Okay. This is our basic formula. If you remember this, then to prove this is very easy. Then we will see some results here. Using this formula we will see the result. See, first we will find out the value of cos pi by 2 minus theta is sin theta. We will prove this. Okay. Now see here, left hand side is cos pi by 2 minus theta. Okay, again use this formula. What is a? A is pi by 2 and b is theta. In this formula you keep the value of a pi by 2 and b theta. Then this becomes cos pi by 2 cos theta plus sin pi by 2 sin theta. Now from our table 0 to 90 degree, what is the value of cos pi by 2? See here, since cos pi by 2 means cos 90, its value is 0, and sin pi by 2 means sin 90, its value is 1. Keep that value here. This will be 0 into cos theta plus value of sin pi by 2 is 1 into sin theta, and this will be 0 plus sin theta, that is equal to sin theta. In this way we have proved cos pi by 2 minus theta is equal to sin theta. Okay, first result. In this way we have got our first result. Then we will see the second result. Cos pi by 2 plus theta is minus sin theta. Now here for plus you use this formula. For plus you use this formula. See here, again you take left hand side, write down cos pi by 2 plus theta, and using this formula this will be cos pi by 2 cos theta minus sin pi by 2 sin theta. Now what is the value of cos pi by 2 is 0, means this is 0 into cos theta, this is minus, value of sin pi by 2 is 1 into sin theta. This will be 0 minus sin theta is equal to minus sin theta. In this way we have got the second result, cos pi by 2 plus theta minus sin theta. First result, second result. Okay. Now we will see the third result. We have to prove sin pi by 2 minus theta cos theta. Now see here, in this result what is given? Sin theta means cos pi by 2 minus theta. Take here left hand side. For this sin pi by 2 minus theta, see value of sin theta from our first result. Sin theta can be written as cos pi by 2 minus theta. Therefore, I can write this cos pi by 2 minus, what is theta here? Theta is pi by 2 minus theta. Okay. See here, from this result first, sin theta can be written as cos pi by 2 minus theta. Here theta is our this angle. Okay, therefore sin theta I am writing cos pi by 2 minus theta. Now open the bracket. If I open the bracket, this will be cos pi by 2 minus pi by 2 minus minus plus theta, and this plus minus will get cancelled. I will get cos theta. In this way we have proved sin pi by 2 minus theta is equal to cos theta, and in this way we have got our third result. Okay, now we will prove the fourth result. Sin pi by 2 plus theta is equal to cos theta. Okay, this is our fourth result. We will prove this. Now take again left hand side. Again by using our first result, I can write this sin pi by 2 plus theta as cos pi by 2 minus theta. Theta is our pi by 2 plus theta. Now open the bracket. This will be cos pi by 2 minus pi by 2 minus theta, and this will be cos minus theta. Okay, but we know that cos minus theta is cos theta. Therefore this becomes cos theta. Okay, equal to right hand side. Okay, in this way we have proved sin pi by 2 plus theta is equal to cos theta. This is our fourth result. Okay, now we will prove our fifth result, tan pi by 2 minus theta. We will find out the value of this tan pi by 2 minus theta, and similarly we will find out tan pi by 2 plus theta. Then we know that this will be sin pi by 2 minus theta divided by cos pi by 2 minus theta. And what is the value of sin pi by 2 minus theta? That is cos theta. And value of Cos pi by 2 minus theta is what? Sin theta. Then I will get this value of cos pi by 2 minus theta is sin theta, and we will get cot theta. Now this will be what? This will be sin pi by 2 plus theta, and this is cos pi by 2 plus theta. What is value of sin pi by 2 plus theta? That is cos theta. And value of cos pi by 2 plus theta from our this result. Value of cos pi by 2 plus theta is minus sin theta. I will write that. And I will get here minus cot theta. Okay. In this way, we have proved the 6 results. If you remember this formula, this is your basic formula. You remember this basic formula. From this formula, we are able to derive the proof of this and also these 6 results. Okay. Let's see the theorem third. Now, what is the theorem? For any two angles A and B, sin A minus B is equal to sin A cos B minus cos A sin B. Okay. Now see, in the proof from result 1, we know that cos pi by 2 minus theta means sin theta. Okay, we will use this. Now this sin A minus B, our theta is now here A minus B. In this formula, instead of theta, I will keep the value A minus B. Sin theta is cos pi by 2 minus theta. If theta is A minus B, now this becomes cos pi by 2 minus A minus B. See here, theta is our A minus B. In this formula, I am keeping value of theta A minus B. Therefore, sin A minus B will be cos pi by 2 minus A minus B. Now, open the bracket. This will be cos pi by 2 minus A plus B. Okay. Now, I will write this cos in the bracket. I will take these two terms together. Pi by 2 minus A plus B. Now you use the formula of cos A plus B. What is that? Since you write down formula, cos A plus B means cos A cos B minus sin A sin B. We will use this formula here. Now what is A here? A is this, pi by 2 minus A. Cos B as it is. Sin pi by 2 minus A sin B. We are using this formula. Cos A plus B. A is this, B is this. Therefore, cos A means this, B minus sin A sin B. Now, from our result, we know that value of cos pi by 2 minus theta means sin theta, and sin pi by 2 minus theta means cos theta. From our result, just we have proved this can be written as sin A from this formula, cos pi by 2 minus theta. Okay, this is sin A, this will be cos B, and this will be cos A sin B. Okay, in this way we have got sin A minus B is equal to sin A cos B minus cos A sin. We have proved this theorem third. Now we will prove the theorem 4. In the similar way we will prove this. Again you know that sin theta means cos pi by 2 minus theta. You write down. Again we know that sin theta means cos pi by 2 minus theta. Therefore write down this sin A plus B cos pi by 2 minus A plus B. Okay. Then open the bracket. This will be cos pi by 2 minus A minus B. If we open the bracket and take this in one of the bracket. Now use the formula of cos A minus B. What is our first formula cos A minus B? That is cos A cos B plus sin A sin B. We will use this formula here. Then this sin A plus B will be, see here, cos A. A is here, pi by 2 minus A. Cos A cos B plus sin A. A is instead of A, pi by 2 minus A sin B. Again from our result we know that cos pi by 2 minus theta means sin theta. Therefore this will be sin A cos B plus, and again sin pi by 2 minus theta means cos theta. Therefore this will be cos A. And in this way we have proved sin A plus B is equal to sin A cos B plus cos A sin B. Okay, again we have to remember these two as a formula. Okay, these are formulae for sin a plus b and sin a minus b. In the similar way we will prove our next theorems. Let's see. Here we have to prove for any two angles a and b, tan a plus b is equal to tan a plus tan b divided by 1 minus tan a tan b. Okay, now we know that tan theta means sin theta divided by cos theta. Therefore, in the solution, you write down tan a plus b means sin a plus b divided by cos a plus b. Now, you write down this formula sin a plus b here. Sin a plus b means sin a cos b plus cos a sin b. And we have also derived the formula for cos a plus b. What is that? That is cos a cos b minus sin a sin b. See, in the formula there is 1 in the denominator. First term is 1, means here we need 1, and to get here 1 we must divide numerator and denominator by cos a cos b. Therefore you write down divide numerator and denominator by cos a cos b. Then I will get here tan a plus b as, in the next step you divide numerator and denominator separately by cos a cos b. Therefore this will be sin a cos b divided by cos a cos b plus cos a sin b divided by cos a cos b, and this will be, you write down here. Now what is this? Here cos b will get cancelled, sin a divided by cos a will be tan a, plus here cos a will get cancelled, sin b divided by cos b will be tan b divided by, here cos a and cos b will get cancelled, remains only 1. Here sin a divided by cos a will be tan a, and here sin b divided by cos b will be tan b. In this way we have got the formula for tan a plus b as tan a plus tan b divided by 1 minus tan a tan b. In this way we have derived this formula. In the same way you can get the proof of second. See here, for that you write down tan a minus b means what? Sin a minus b divided by cos a minus b. Then you keep the value of sin a minus b, that is the formula for sin a minus b, that is sin a cos b minus cos a sin b divided by, what is the formula for cos a minus b? That is our first theorem, and that is cos a cos b plus sin a sin b. Now see the right hand side of this theorem, this formula. Here is 1, and to get here 1 again I have to divide numerator and denominator by cos a cos b. Therefore you write down divide numerator and denominator by cos a cos b, and you will get here tan a minus b as sin a cos b minus cos a sin b divided by cos a cos b. Again here cos a cos b plus sin a sin b divided by cos a cos b. In the next step I will divide separately by this cos a cos b, and this will be cos a cos b divided by cos a cos b plus sin a sin b divided by cos a cos b. Now here in the numerator this cos b will get cancelled, and this will be sin a divided by cos a tan a. Here cos a will get cancelled, sin b divided by cos b will be tan b. Okay, divided by, see here cos a cos b will get cancelled, here remains 1 plus sin a divided by cos a tan a and sin b divided by cos b tan b. In this way we have got the formula tan a minus b is equal to tan a minus tan b divided by 1 plus tan a tan b. We will derive two results using this theorem. As we have got the formula for tan a plus b and a minus b, we will get the formula for cot a plus b and a minus b also. What is given here? If none of the angles A, B and A plus B is multiple of pi, then cot A plus B is equal to cot A cot B minus 1 divided by cot B plus cot A. Why it is given that if none of the angle A, B and A plus B is multiple of pi? Here, if angle is multiple of pi, see value of cot at pi, that is at 180 degree, is not defined. Value of cot at 180 degree is not defined. Therefore, it is written as none of the angle AB, A plus B is multiple of pi. If I keep the value of A here, pi, or multiple of pi, then here this right hand side becomes not defined. If I keep the value of A plus B as pi or multiple of pi, then left hand side also becomes not defined. Therefore, if angle AB or A plus B is multiple of pi or pi, then this function is not defined. Therefore, we have written that none of the angle AB and A plus B should be multiple of pi. Okay. Now, for cot A plus B, how can we derive this? See, we know that cot means cos divided by sine. Cos A plus B divided by sine A plus B. Now, you keep the formula for cos A plus B, that is cos A cos B minus sine A sine B divided by sine A cos B plus cos A sine B. To the right hand side in the numerator there is 1, means I have to get here 1, and for that I have to divide the numerator and denominator by sine A sine B. Therefore, you write down divide numerator and denominator by sine A sine B. Then I will separately divide by sine A sine B. Now what will be this? See here, cos A divided by sine A means here cot A. Cos B divided by sine B means cot B. Here sine A sine B will get cancelled 1. Here sine A will get cancelled, cos B divided by sine B means cot B. And here sine B will get cancelled, cos A divided by sine A means cot A. And in this way we have got the formula, just very simple. Okay. Now see, for this formula in the similar way you can write cot A minus B means cos A minus B divided by sin A minus B. Then put the formula of cos A minus B, that is cos A cos B plus sin A sin B divided by formula of sin A minus B, that is sin A cos B minus cos A sin B. Again you divide numerator and denominator by sin A sin B. If we divide numerator and denominator by sin A sin B, then here we will get cos A divided by sin A means cot A, cos B divided by sin B cot B. This will be sin A sin B will get cancelled, here remains 1. Here sin A will get cancelled, cos B divided by sin B means cot B, and here sin B will get cancelled and cos A divided by sin A means cot A. Okay. In this way we have got the formula for cot A minus B. Okay. It is very simple, and see, this result is very frequently used. There is no need to derive the formula, only 6 theorems and their proofs are very important. All the 6 theorems see here which we have derived, I have written here. This cos A minus B is equal to cos A cos B plus sin A sin B. This is our basic formula, and using this formula we have derived all these formulae. If you remember this basic formula, then from this formula we have derived formula for cos A plus B, then for sin A plus B A minus B, tan A plus B A minus B, and cot A minus B A minus B. Okay, these 1 2 3 4 5 and 6 formula, you remember only these 6 formulae. There is no need to remember the formula of cot A plus B and A minus B, because if you find the value of tan A plus B, take reciprocal of that, you will get cot A plus B. Value of tan A minus B, you take the reciprocal of that, you will get cot A minus B. Therefore, no need to remember these two formulas. No need to remember these two formulas of cot A plus B and cot A minus B. No need to remember these formulae. You only remember these 6 formulas. Only these 6 formulas are important. Okay. And now see, these 6 can be reduced into 3. See here, this cos A minus B is actually cos A cos B plus sin A sin B. And what is the formula for plus? See, for plus also here is cos A cos B, here is sin A sin B. But for plus here is minus sign, and for minus here is plus sign. Means if I take here minus sign, here is plus, and if I take plus sign, then there is minus. If you take here the upper sign, then here you take the upper sign. If you take here below sign, then below. For minus there is plus, and for plus minus. See here, for minus there is plus, and for plus minus. Means these two formulae I have written in one form. Now see, for sine A plus B is what? Sine A plus B is sine A cos B plus cos A sin B. And for A minus B, again sin A cos B, cos A sin B. But see, for sine, if here is plus, then to the right hand side is also plus. If in the left hand side is minus, then here is minus. Means for sine, plus to plus, minus to minus. Means here you take plus, plus. If there is minus, then minus. These two formulae I have taken here together. Okay. For tan also, tan A plus B is what? You write down the formula for tan A plus B. That is tan A plus tan B divided by 1 minus tan A tan B. Means for the plus formula, if there is plus to the left hand side, then in the numerator is plus and in the denominator is minus. And what happens for minus? See, if minus sign is to the left hand side, then in the right hand side, in the numerator is minus and denominator is plus. Means here plus plus, in the denominator minus. If here is minus, then minus, in the denominator plus. Means this formula can be written as minus, this will be minus, and this will be plus. Means these two formulae I have written in one. I have combined these two formulae in one formula. Means we have to remember only these three formulae. You only remember the formula of cos A minus B. See here, for A and B, both here are cos, here are sin. And for sin, here is combination of sin cos, cos sin. One of the angle is A, other is B. And for cos, if here is minus, then here is plus. If here is plus, then minus. And for sin, plus plus, minus minus. And for tan, if here is plus, in the numerator plus, denominator minus. If here is minus, then in the numerator minus and denominator plus. You remember these formulae? If you remember these three formulas, then it is very easy to solve the problems in exercise 1. Okay? Then again, we will collect the results which we have got in this lecture. See here, this we have to remember as formulae, and this we have to remember as results. And what is that? Cos pi by 2 minus theta means sin theta, and sin pi by 2 minus theta is cos theta, and tan pi by 2 minus theta is cot theta. Again we have derived cos pi by 2 plus theta minus sin theta, and sin pi by 2 plus theta, that is cos theta, and tan pi by 2 plus theta minus cot theta. We have derived these 6 results also. We have derived the proof of these 6 theorems and also these 6 results. Okay. Also we have derived the proof of these two, but these are not very much important. You only remember the proof of 1 to 6 and remember these as formulae, and also you remember these results. Okay students, you only remember these 6 formulae and these 6 results. Or if you don't remember the results, it's okay. Using these formulae you are able to find these values. No need to mug up or no need to remember these results. If you solve so many problems which are based on these results, then these results will be automatically memorized by you. And if you remember this 6 formulae, then to solve the problems in exercise 3.1 is very easy. We will see exercise 3.1 in our next lecture. Okay, see you in the next lecture. Till then, goodbye.